Dole! I switched the heaters around. I'm so naughty, aren't I? Hello, and welcome to the follow-up discussion on why I have remade my space heater video. Now, this is going to be all over the place, and if you got here without seeing the other video, I will throw up a card. There will be a link down below. So basically, I'll give you a little bit of a refresher. I just made a video on technology connections about a thing that's always frustrated me, and that thing is simply that, in the US at least, generally space heaters are all 1500 watt heaters, and they all therefore release 5120 BTUs per hour, whatever. And this is not the first time I've made this video, because back in my old YouTube days, I made it, and it did not go over well. So on my old channel, which is pretty much dead, so I wouldn't go looking for it, but if you want to find some things, you might find some interesting things. Anyway, I've taken down this video because I got tired of dealing with it. So this video itself is actually a follow-up to the first video I made. Now, to be fair, the first video I made, I believe I titled, I should open them both up, shouldn't I? Okay, so that video is actually a follow-up to a quick video that I made, and to be fair, the title is very clickbaity, called How to Choose a Space Heater or Space Heaters a Conspiracy. As you can see, I look lovely. And this video, this is weird. Okay, a couple things. I thought I made this longer ago than I did. Apparently it was only about 5 years ago. I thought it was more like 8 years ago. This video did not get much traction, but the reason why I did a follow-up, and it's interesting because that comment's not there anymore. I wonder if that... Let's get back on target. So anyway, I made that video and I talked about all space heaters are 1500 watts. If they can all put out 1500 watts, how is one better for a larger room than another? It would seem to me that if we're fighting a thermal load and they both can put out the same amount of heat, then they're equally as effective at heating the room. So I got someone who got in a big argument with me over how incredibly dumb and wrong I was. So I decided rather than just let that stew, I would actually run an experiment. So this is at the house that I grew up in, and this is what was at first my bedroom. Then when I moved out, it became my brother's bedroom. Anyway, so this room gets really bad heat. It's the room that I mentioned in the previous video, so it was always cold. And I thought this would be a perfect room to do an experiment on whether or not a small space heater can effectively heat the room worse than a large space heater. So the heaters that I compared in this video were, and this is actually unintentional, this same exact model, except an older one, and a Polonus oil-filled radiant or convective heater. At that time, they were listed as for a large room. So you'd have large rooms, pretty much the only heaters that were for a large room were the radiator style, and these little ceramic ones were always said to be for a small room. So all I did was I ran an experiment where I let the heaters run for a half hour each, compared how much warmer the room got in that half hour. So I set up a kilowatt like I have done now, and I also set up a clock just to show the passage of time. And let's see here. 65.8 degrees in here. So this heater in a half hour was able to increase the temperature in the room by about 5 degrees. Pretty simple, right? So I had this, pretty much exactly this heater running on high for 30 minutes, and then we saw how much warmer the room got, and it was 5 degrees. Now I'd say that's pretty good for a heater that's only supposed to heat a small room. And so then I repeated the experiment with an oil-filled heater like this. So here we go. This is the supposedly large room. Oh, and you know what? Hang on. I'm a Dumbo. I have the box still, I think. No. Dang it. Anyway, I thought I had the box. So this heater is for a large room. And after, let's see, I'm just scrubbing through this because you really don't need to Tell you what, I'll put a link to this video, which is now unlisted, in the description if you want to see it. Yeah, if you want to, go ahead, but please don't feel like you need to. Please don't watch it. Anyway, let's continue. So where did I go? How did I do this? I should have, well, first I talked about it's 1500 watts. I showed the meter. And this is probably me talking about stuff. Okay. So we started 6. Well, I would say that if this oil-filled space heater is really so much better at heating larger rooms, that we should be at much more than 62.6 degrees right now. Oh, apparently I started. I now have this heater plugged, just so that way you are aware before I get started. It is about 8 to go. Since I turned the other heater off, so it's 61.3 degrees. And what I did, I probably mentioned it, but what I did was I actually opened the window in the room to try to get the room back to the same starting temperature and waited about an hour or two for things to settle before I started this again. So the room started at 61 point what? 61.3. Then after a half hour of running, 62.6. So it didn't heat the room much at all. Now, before you yell at me, as many people did at the time, I'm aware that oil-filled heaters take a long time to heat up. That's just part of how they work. So I let it go for another half hour. I'll give this thing another half hour. Let's see what we get. We're at 64.7. Okay, so I gave it another half hour. So even after an hour of running with it on high, with the thermostat all the way up, it still didn't raise the room as much as this little thing, which is supposedly for a small room. And the reason why that happened was because the oil-filled radiator heaters, they get hot. So because the whole thing gets hot, the thermostat itself actually heats up, and so they actually limit themselves. They cycle on and off even when you have them as high as they will go. So that to me was also like, why is this called why did they say this is good for a large room heater? Not only does it not put out as much heat as this, it limits itself because of its design. Unless it has some sort of airflow to push air past the thermostat to actually get a reading of the room, it's going to think, oh, I'm up to temperature, let's shut off for 2 or 3 minutes. And so, as I show in this video, it's cycling on and off, even though it's as high as it will go. Whereas this little thing, because it has a fan, the thermostat, the top of it, doesn't actually get that warm. It's constantly pulling in fresh air from behind it, so it doesn't get that hot. And that means it will run full blast as long as you want. And indeed, that's what it did. So this actually was able to put out 1500 watts for a half hour, which raised the room temperature by 5 degrees, whereas the large room oil-filled convective heater was only able to raise the temperature by 4-ish degrees in twice the amount of time. So I think that was pretty clear proof that the room size ratings are just dumb. And because you should expect that the oil-filled heater should be able to heat the room faster if it can heat a larger room. Unless there's some other crazy definition of, I mean, you're going to need to have more heat. It's just, that's what it is. In order to heat a larger room, it has to be able to produce more heat. And therefore, in the same space, it should be able to heat that space faster. But it can't. Now, if you take a look at the likes-dislikes ratio of this video, it's pretty awful. And the comments just don't make any sense. And a lot of people are, like this guy, in reality radiators are not meant for instant heat. They don't heat in 30 minutes. I know, that's why I let it run for another 30 minutes. If they definitely get up to temperature in a half hour. If they didn't, that would be ridiculous. And you can see here I am yelling at the people because people are just the best. And this is basically it. When the net BTUs added to the space equals the BTUs leaving a space, you've achieved equilibrium. It's as simple as that. Which is basically what I thought I was being a rational human being making this video, showing this experiment, and being like, do you see how this doesn't make any sense? And yet all these people were replying to me about how wrong I was. So And this is what's so frustrating. The test is not a fair comparison between the two heaters. The small heater works with a heating element and a fan, so heat energy from the element is transferred directly to the air. Exactly. The element in the oil-filled heater has to first transfer heat energy to the oil, which then heats the air. Of course it's going to take longer to heat as a liquid to work. Just because the heater can bring the temp up to quicker doesn't make it a better heater. Okay, that's true, but the objective betterness of the heater isn't what's in question. It's how much heat can it produce. The oil-filled heater is limiting itself. I'm sorry, that's what it's doing. And I was just so frustrated by all these comments. Thanks for the waste of time on your failed experiment. You buy the small one because it's cheaper and smaller. You buy the oil-filled because it's silent, doesn't dry out the air, and many have digital thermostat controls that are more precise, a lot of shut-off timers. So this is also just weird because he's, I guess, kind of agreeing with me. They both have heating elements that draw the same amount of electricity, so they will heat about the same. Size has nothing to do with it. Basic thermodynamics. That's what I'm getting at. This is like the only relevant comment. I opened the windows I opened the shades. That wasn't good of me, but in any case, it was still pretty. It was a rough difference, I'll tell you that much. And it's clear that the oil-filled heater, because it's cycling on and off like that, it's not possible for it to produce the same amount of heat. I showed on the kilowatt that both heaters pull. In that case, I think they were like 5 watts apart. So they're pulling almost the exact same amount of energy from the wall, which means they're releasing the exact same amount of heat. But the oil-filled one keeps turning itself off because the thermostat is fooled into thinking that it's warm. One person commented, so as of now, I'm making this video before it's public, but one person commented from my patrons that they've had an experience with an oil-filled heater. It's the same thing. They can't continuously release heat, and he tried to adjust the thermostat, which caused the overheat cutout to trip and broke the heater. Because it's like, yes, fundamentally this video is all about how annoying marketing is, but I was kind of afraid to make this video again because I have all of these people yelling at me, figuratively, and this likes dislikes bar is just terrible. Now I will grant you, this video, it's not a good video. It's not made well because this was before I really took YouTube seriously. But I did want to put out there, folks, this doesn't matter. They're both 1500 watts. One's not going to be better at heating a larger room if they're both 1500 watts. So that was basically that. That's how this happened. It wasn't great. What I do want you to know through seeing this is that I have actually done an experiment to verify that a large room heater is no better at heating than a small room heater. And I wasn't even expecting the result I got. I was expecting it to be exactly the same. But I didn't realize how much the thermostat of the oil-filled heater was limiting itself. So I was actually quite surprised that this, cheap small room heater was able to do what it did. But so let's talk about some other things. The reason why I have this candle burning next to me is to illustrate that all of the energy that is currently being released by the flame is coming into the room. So basically all of the fuel that is being combusted, the paraffin, is ending up as energy in the room. There's probably a few losses somewhere, but because this entire thing is in the room, I know that basically I could put a box over this and collect all that energy. It's no different from a space heater. All of the energy that's coming out of it is going into the room. Neither of these have an exhaust, like a furnace, which needs to have an exhaust because it will kill you if it doesn't with carbon monoxide and all that. So that's the reason why electric heat, you can say with confidence, is 100% efficient, because there's no heat going outside, it's all coming here, and any losses that do occur through the motor or even say the cord is heating up because of resistance, that's heat. It's coming into the room. If the unit's releasing 1450 watts and 50 watts is being wasted in the cord, that 50 watts is still heat. It's still the action we want. Even light, like the tiny little light at the top of this heater, as soon as it hits a wall, that's going to turn into heat. But anyway, I wanted to remake this video because part of what I want to do with this channel is to teach people things. And this is just a fundamental thing about how energy works, how energy in terms of heating and cooling, how we need to learn about it. So if energy is entering a space, then that's the energy we have. So, and because we can quantify it, because we have something like 1500 watts, if you go to a store and you see a bunch of space heaters for sale and they all say 1500 watts, you should know that, well, one of them is not going to be able to put out more heat than the other. And particularly the oil-filled ones, they're expensive, but I don't mind that because of the safety and other benefits they have. But like the Eden Pure, which was the one I was calling out without actually saying its name, and those other like infrared quartz things, not the radiant ones, I read apparently the idea is they have infrared quartz heating elements that heat up like metal plates inside of them, and they act as a heat sink, so it stores heat just like the oil in a radiator. But I mean, like, that just delays the output of the heat. This thing is like, hey, heat, there you go, have all of it, because the heating elements are very tiny and it has all the little fins on it to just push them right out. Same with the wire-filled heater. They don't have thermal mass, they're just pushing it all out immediately, which means they're very effective at heating the room, because as soon as you turn that on, boom, that heat's coming out right away. If you have something like an oil-filled heater or those infrared quartz things, there's a delay because that heat is being first added to something which is then releasing it more slowly, there are reasons to do that. It can be more comfortable, but it is not more efficient and it is not more effective. That's all that it is. It's a delay. It's basically like saying this candle, the heat that the wax, or let's say something differently. Say that instead of this candle being open to the air, I had a flower pot on top of it. Have you ever seen those things? This is hilarious. Where you put like 3 tea lights underneath a flower pot and then the candles heat up the pot and therefore it radiates the heat. I've tried this thinking that maybe the radiance of the warm pot might be effective, because the thing is you do lose the heat goes straight up to the ceiling. So yes, it does go in the room, but it's not going in a very good place. But still, fundamentally, you only have the energy in the candle flame, and a typical candle flame, if I'm not mistaken, is something like 70 watts or something. So if you have 3 tea lights, and tea lights have tiny flames, but if you have 3 tea lights burning, you're maybe getting 210 watts, probably more like 150. So all that energy is still going into the room. If you put something to stop it and release it in a different area, you might be able to make the area around it more comfortable. But that's the point of the video, is that if we're talking about a heater that's to heat a room, that's what the room size ratings are for, then we're not necessarily talking about a heater that's meant to keep you warm, like the little personal heater that I showed. We're talking about a heater that's meant to heat the space, a space heater. And for that application, storing the heat for use later is just not needed. It may make it more consistent, because you won't have this cycling on and off. It's not 100%, 0%. It can be, 45% or 20% or 80%. But it's still not more efficient. It's just a mechanism between the heat generated and the heat escaping. And so yes, there can be applications where the heat can be transmitted differently or it can be put out in a better place. I'm not disputing that. But if you're trying to heat a room, if that's the task you're trying to accomplish, there's no sense in delaying that heat. Just let it out, because it's gonna heat the room. And so this baseboard heater here it's actually really annoying that it considers itself a medium room heater when this is small, because this hardly moves any air at all. I mean, we know that it doesn't move air on its own action, it's just convection causing the air currents that form, and they're not very significant. Whereas this thing is blowing quite a lot of air out the front. So just like in the experiment that I did, it seems to me backwards. This should be better at heating a larger space than this, if anything, because this is not aided in moving its air around, and in fact, just like a candle, it mostly goes straight up. So if you're near this thing, it's going to feel warm, but if you're not from it, you have to rely on the current hitting, or the convection currents going up to the ceiling and then just circulating around. And point 2 is that just happens no matter what. The reason why this can be an effective heater is that convection will spread the heat around. It's better if you have something to help, like a fan, which is why this has a fan in it, or if you had a ceiling fan, you could turn on a ceiling fan on low to spread that heat around. But anyway, I'm rambling a lot, as you can probably tell. But so to summarize, if you can call it a summary, I wanted to remake this video because every single time I go to a store and I see a display of space heaters, it's just so annoying to me. It's like 1500 watts, 1500 watts, 1500 watts, 1500 watts. And I have to say, they're all the same. What's different between these two? They're all producing 1500 watts of heat. Some of them do that in a radiant fashion, which can be better in some circumstances. Some of them are silent. Some of them have really big fans. But they all put out the same amount of heat. And it's easy to verify, it's easy to check, and it's electric heat. It's 100% efficient no matter what you do. So I wanted to make this video because I really feel like it felt like from my old video that a lot of people just don't get it. And to be fair, I didn't really explain it. I didn't really explain much at all the mechanism by which heat leaves a room and how that's relevant to heat being replaced by something like a heater. I mean, I touched on it, but I didn't really explain it much. But it's just shocking to me how by calling out misleading labels and then actually running an experiment to show how misleading they are, just how poorly that went. And I'm hoping that this time it goes better. So here, let me put forth to you, if you know anything, if you know of any reason why this heater, which is 1500 watts, let's assume they're both 1500 watts, because this one actually is this one's 90 watts more powerful, but let's just assume they're both the same. If you know of how this room can be more effective for a larger room, let me know. There are certainly advantages and disadvantages. Maybe, as someone pointed out to me, when they say large room, they just mean this is physically larger, so you wouldn't want it in a tiny room. I don't think that's what they mean, particularly because you'll see that that stacked ceramic heater was labeled as medium, whereas this one is not. But if you are an HVAC engineer or designer and you know of a way that this heater would be more effective at heating the same space or more efficient, let me know. There's my calendar alert going on in the back. But I'm just really skeptical that any electric heater is going to be better at heating a space if they are both able to put out the same amount of heat. Because the walls are the same, the thermal loads are the same. The only difference is where the heat's coming from and what direction it's going. But again, you've got convection, which will spread that around. So it's just, to me, a bunch of nonsense, which is why I titled it the way I titled it. But as I said before, if you have any thoughts or anything, please leave them down below. If you have anything that you know of that proves me wrong, please leave them down below. Because I would gladly revisit this video if it turns out that, yes, this does have some advantage to a larger room. But the thing is, my experiments, my intuition, and my knowledge of thermodynamics just says that can't be. But I'm willing to accept evidence to the contrary.